Welcome, your grade A mathematics teacher Beatrice here. Today we are talking about formulae relating moments, and we are going to look at a number of formulae and a number of proofs, and we start by proving. So we say prove that mu2 is mu2 prime minus mu1 prime squared. What do we mean here? We mean, you recall we saying that we usually use moments about a point to get moments about the mean. So here we are saying that mu2, that is the second moment about the mean, is got by taking the second moment about a point and subtracting the square of the first moment about a point. So that's what we are going to see. And besides that, we are also going to see how we get mu3 and mu4. That is the third and fourth moments about the mean using moments about a point. So we start by letting D, just the D with that we know, the deviations from from xi's. So D we know is given by every x minus a, where a is the assumed mean. We call that 1. The same, we can write it as x is equal to a plus d. So we start by considering, first of all, we label that as 2. So we consider, first of all, we consider 1. We have seen that d is x minus a. So what we do first is that we introduce summation. And when we introduce summation, introduce the summation sign. And of course, now we will not just be summing d, but we'll be summing di's is equal to the sum of xi's minus the sum of a. We can actually say I is equal to 1 to n, I is equal to 1 to n, I is equal to 1 to n. So once we have written that, we can divide through by n. Divide by n each of these terms. So we are going to have sum of di, I is equal to 1 to n, divide by n is equal to sum xi, I is equal to 1 to n, minus a, sum I is equal to 1 to n of 1. Because we said a is a constant, we divide that by n and divide that by n. And you know very well when we do that, just like sum of xi's divide by n usually gives us x bar, the sum of di's divide by n gives us d bar. So d bar is equal to x bar minus, we said when you sum 1 n times you get n, and that cancels out, and you're left with d bar is x bar minus a. And we can write this starting with x bar. You can write it starting with x bar, and we say x bar is a plus d bar, and we label that as 3. Once we have labeled that as 3, we go back to the original equations that we had, and we take now equation 2. Remember we have worked with 1, so now we are going to take equation 2 and we are going to combine with the equation that we have found here, which we have labeled 3. So we say take 2 and 3. So we have x is equal to a plus d, and we have x bar is equal to a plus d bar. We can actually now solve them simultaneously. We subtract. We are going to get x minus x bar is equal to d minus d bar. So which means we could come and first of all recall that mu2, which is the second moment about the mean, is the sum of x minus x bar, all that squared, divide by n. But now we have found that x minus x bar is the same as d minus d bar. So we can actually write this. Allow me to write it a bit down here. So we can write mu2, which is the second moment above the mean, as the sum I is equal to 1 to n of d minus d bar, all that squared, divide by n. Because we have found that x minus x bar is the same as d minus d bar. And once we have done that, we can expand that expression. We can square d minus d bar. So we are going to get mu2 is equal to the sum I is equal to 1 to n of d squared minus 2d d bar plus d bar squared. We have expanded that expression, and now we can distribute the summation sign. We get mu2 is equal to the sum I is equal to 1 to n of d squared, divide by n, minus 2 d bar, sum of d. All this divide by n. D bar is a constant, that's why we are taking it out, plus d bar squared, sum of 1 I is equal to 1 to n. I is equal to 1 to n. Again, that divide by n. And once we divide that, we are going to get mu2 is equal to sum is equal to 1 to n of d squared over n minus, now you see we have sum of d over n, which is going to give us another d bar. So here we are going to have 2 d bar squared plus what? Here n and that will cancel out. We are going to be left with d bar squared. So we continue and we put this and that together. So we have mu2 is equal to the sum d squared over n is equal to 1 to n minus, we have 2d bar squared plus d bar, so we are going to be left with just 1d bar and minus 1d bar squared. Okay, so we continue. We need to remember, before we do that, first of all, we come here, and this d bar squared can actually be written this way. We have u2 is the sum is equal to 1 to n of d squared over n. Now this d bar can still be written as sum of d divided by n, but now it is squared. And then once we have written that, we recall that d is x. Just allow me to use the capital one I used. D is x minus a. So we come and say u2 is the sum is equal to 1 to n. Instead of writing d squared, we write x minus a squared over n minus sum of x minus a over n, and all this is squared. So this d we have replaced it with x minus a, and everything is squared. So if you look at what we have here, this is mu2, which is the second moment about the mean, is given by, this is actually the definition for mu2 prime raised to power 1 minus, this is what we have in the bracket here, is the first moment about a point, and it is actually squared. So this ends our proof. So we say end of proof. So what have we concluded? We have concluded that the second moment about the mean is given by the second moment about a point minus the first moment about a point squared. That is what we needed to prove. That is what we needed to prove. Having done that, we can still go ahead and do a second proof. So we say prove that mu2, remember we are saying that we use, so prove that mu3, which is the third moment about the mean, is mu3 prime minus 3 mu1 prime mu2 prime plus 2 mu1 prime, and that is cubed. We would like to prove that, and we start by saying now mu3, the third moment about the mean, is given by the sum of xi minus x bar, all that raised to power 3, divide by n. But now we have known that this xi minus x bar can be replaced by d minus d bar. We said x minus x bar is the same as d minus d bar. So we can actually come and write mu3 is the sum d minus d bar, all that cubed, divide by n. So when we have it like that, again we can expand what is in the brackets and we get mu 3. Mu 3 is d is the sum, we have sum outside, is the sum of d cubed minus 3d squared d bar plus 3 d bar squared minus d bar cubed, and we have brackets, or that divided by n. So d cubed minus 3d squared d bar plus 3d d bar squared minus d bar cubed. So distributing the summation, we have sum of d cubed over n minus 3 d bar sum d squared, or that divide by n, plus 3 d bar squared sum of d over n minus of course we have d bar. This is going to be simply d bar cubed, because sum of n and n will cancel out. As you remember, we're saying that when you sum n, if you sum 1 n times, you get n, and you hand the denominator n. So we proceed and put some of these together. Let's see what we can put together. Is there something we left out? We have 3d sum 3. Okay, yeah. So continue. This can be put together to give us another d bar. So we have d bar cubed. So this is going to be sum d cubed over 3 minus 3 d bar sum d squared over n plus 3 d bar cubed. Sum of d over n becomes another d bar, so minus d bar cubed. So we can actually now put the third and fourth term together. So we're going to get sum d cubed over 3 over n over n over n minus 3 d bar sum of d squared over n plus, putting these two together, we get 2 d bar squared. Okay, now we still remember that d, first of all, we can put this back. We remove d bar, so this gives us sum d cubed over n minus 3. 3 d bar is actually d over n, is the sum of d over n. Let's see how we put that together. See how we put this together. We can actually, first of all, just remember, we recall that x minus a is equal to d. x minus a is equal to d x minus a is equal to d x minus a is okay. So remember, this is not d bar squared, it's d bar cubed. It is d bar cubed. So we recall that d is x minus a, and we also recall that d bar, we recall that d bar is equal to sum of d over n. So whenever we have d bar, we can substitute it with sum of d over n. So we continue here and say this is sum d squared over n d cubed. It is d cubed over n minus 3 sum of d over n sum of d squared over n plus 3 sum of d over n, and this is actually cubed. So we can now replace d with x minus a. So this is going to give us the sum of x minus a, and that is cubed over n minus 3 sum x minus a over n sum x minus a squared over n plus, this is not 3 but 2 sum of x minus a cubed over n. So what does that finally give us? This gives us mu 3 prime, that one, minus 3 mu 1 prime mu 2 prime plus 2 mu 1 prime cubed. So this is the end of proof. We have seen that we can get the third moment about the mean by taking the third moment about a point. We subtract 3 times the first moment about a point times the second moment about a point, and we add that to the second moment about a point cubed. So you can now also show that using the same procedure, you can show that the fourth moment about the mean is the fourth moment about a point minus the fourth moment about a point, the third moment about a point, plus 6 into mu 1 prime squared mu 2 prime minus 3 mu 1 prime raised to power 4. So using the same formula, it is also possible to show that. So our lesson ends there. We have been able to show that we usually get moments about the mean from moments about a point. Thank you.